Hey there, guys, welcome back to the channel. We took a very long gap, so on to the next problem, I guess. Uh, so 16 problems completed to the 17th problem. Cheat code 486, predict the winner. Let's see what it is about. We are given an integer array nums. Okay, we have an array called nums, and two players are playing a game with this array. Player 1 and player 2 take turns with player 1 starting first. Both players start the game with a score of 0. At each turn, the player takes one of the numbers from either end of the array. Okay, they have to take either end of the array, elements from either end of the array. Okay, the players take one of the numbers from either end of the array, which reduces the size of the array by 1. Okay, the player adds the chosen number to the score. Okay, the game ends when there are no more elements in the array. Return true if player 1 can win the game. If the score of both players are equal, then player 1 is still the winner. And you should also return true if you may assume that both players are playing optimally. Okay, so let's do one thing. Let's do memorization thing. So try all. Uh, so you got to think for player 1 and player 2. Hopefully, let's do one thing. Let's take index. Okay, if index is equals to the length of I think we don't see index, we have to see L and R. L comma R. If L is less than R, return, but we need to know the player's innings. So we need to know player one. Player. Okay. You may assume that both players are playing optimally. So if both players are playing optimally, then initially player 1 would take the highest value, I guess. If between 1 and 2, he choose 2, then player 2 can choose from 1 or 5, player 2 choose 5, and player 1 will be left with 1. Hence player 1 will, uh, okay. If player one choose, the player one will be the starting person. So here, player one can choose between one and seven. So player one initially chooses one because if he chooses seven, then player two will choose 233. So by choosing one, he will like the player two will have to choose from five and seven, which will open the spot for 233, which makes the uh, person winner, and the length of numbers is 1 and 20. So yes, we can try a huge thing here. Let's see. We need to know the player's turn and the player's value till the point. Player one and player two. If the values are 1 to 20, then I guess we can try it out. Player one is greater than or equals to player. Now, also we need to know the turns, right? We know which player took the turn previously. Try how player one can choose between one and R. So it is we have four choices here. Player one can choose the first element and it decides if turn one player one plus nums of n comma player two and will return. But there is another choice too. Choose first or last. There are two choices. But how would we know to choose the maximum one. Oh shit. You cannot pass a integer value and expect a boolean value in the end. One contains from 1 and 2. But all like what we're trying to do now is 5, take 2, second one can choose 5, 5 1, okay, 1 5, 5 2, 7 and 1, 3 and 5, 3 and 5, 7. Let's see. If they choose greedily, player 1 can choose strategically. Player 2 should choose in a greedy approach. Huh? The player 2 thinks greedily. Let's do one thing. If their one is greater than or equals to, choice one, choice one, and choice two. Well, this worked out well. I don't know for sure though. Well, let's try. 2 or 8. Clear one can choose 8. 2 can choose 6. 1 can choose 55. Hmm, let's go through the problem again clearly. It take turns, okay? Player 1 starting first. Player 1 should start first. Both players start the game with score of 0, okay? At each turn, the player takes one of the numbers from either of the ends. This reduces the size of the array by 1. The player adds the chosen number. The game ends when there is no more elements in the array. Return true if player 1 can win the game. The score of both players is less. We may assume that both players are playing optimally. And what does it mean when it's optimally? Because player 1 choose 2, player 2 to wait. Player 1 have to choose from 4 and 6. Or if the player 1 chooses 8, player 2 will choose from 2 and 6. Okay. Let's see. Let's see help from the ChatGPT. Indeed code 486, right? Oh shit. This turn the system. Player can achieve current when someone picks a number. How does this change the advantage? Well, then the next turn the opponent will have advantage. Load command equals to number. Just one thing, let's take a small break. I cannot able to process. Let me take a small break and get back to you. So guys, back. Let's go from where we have left. Now let's. I actually took one full day to come back. So let me go through the question again. I have two players. Each one takes turns. Initially, the score will be zero for the both, and we can select values from the nulls from either end at each turn, and we have to check if player one will have more value than the player two or not. So our approach didn't work, so let me ask ChatGPT 486 help me to figure out the code 486. This is my approach. Let's see now. The, the question here is what actually is the optimal selection mean? I know choosing choosing greedily and what really is optimal selection at that instance of time. So I'm not choosing greedily, but what is really optimal selection at the instance of time? Okay, this is something. Optimal does not mean greedy. Greedy equals choose the move that immediately gives the best number. Okay. Optimal is choose the move that maximizes your final winning score within the opponent plays perfectly. Okay. Not your immediate win. Okay. Think of it like okay. A greedy move is capture the biggest piece right now. An optimal move is pick the move that leads to winning the game, even if it sacrifices the piece. Now let's rephrase cheat code 486 with the right perspective at every step. You don't choose to maximize your score, okay? You choose to maximize your final score difference. After both players play optimally, this difference is critical. Instead of tracking player one score versus player two score, track maximum score difference the current player can achieve. Okay, because on player one's turn they want to maximize the final difference. On player two's turn they want to maximize player one's final difference. On player two turn they want to minimize player one's final difference because on player one's turn they want to maximize the final difference. Okay, this is the correct meaning of the optimal play. Let's make it concrete using a function. Okay, this is pretty clear to figure. Okay, but optimal player two should think like which move leaves player one the worst possible long-term position, not which number is bigger right now. Okay, question one: if the current player picks from shuffle, what happens next? Opponent plays optimally on range 1 L plus 1 R. So the final advantage becomes norms of L minus advantage of L plus 1 R. Opponent plays optimally on range. Okay. Is the pick is the pick now Safar? Okay. What is the optimal move? Current player picks the move with the maximum final advantage. This is the optimal move. Okay, that's fine. Player makes a move. Opponent responds in the worst possible way. Player evaluates the final outcome. It is exactly the mini-max formula. Player makes a move. Opponent responds in worst possible way. Player evaluates the final outcome. Player chooses the move that leads to the best final result. Player chooses. This is what optimal means. Notice you no longer need to track player 1 and player 2 separately. Okay, the recursion boils down to if L of R equals to best advantage. Starting at L, R, and player 1 wins if. Okay, so the first move N minus 1 will be R. L, L R equals to best. Before I give you the final answer this, if you write your function so that it returns the best possible final difference instead of Boolean win loss, can you now see why it captures optimal play? Okay, L comma. So what basically let's try doing it. Let's define a function and what should we do with the function? Okay, so as it named the function, let's keep the function name the same. It sounds more intuitive. Advantage. So L comma R. If L is equals to R, nums of L minus advantage. Since nums of L, okay, since we only have one element left, we are returning that one element in the base case, and here if we take L, if you take R, what what is the advantage? So what we are doing here, we are trying to take the maximum advantage or minimize the other's advantage. If whatever is returned is greater than 0, so simply put, either all the advantageous values go to player 1 or to the player 2. So if you select L now, then the next player will select either R or L plus 1. You are not using the function. This didn't seem to work. One one yeah. Let's go through it again. Advantage of L comma R equals to. So let's go through the Q1, Q2, Q3 again. We will get to know more in detail. Opponent plays optimally on range L plus 1 comma R. So the final advantage becomes what happens next? Opponent has to play advantage. Okay, if they pick so far, then the advantage is this. Okay, what is optimal move? Current player picks the move with the maximum final advantage. Maximum player makes move. Opponent responds in the watch possibly. Oh, got it. Toss -2. There is a lot of dynamics here. I couldn't get to understand properly what's going on. Let's see. Okay, understood the base case. Okay, so we're going forward to a particular point. So number of one is selected. If we select L, then the other one will have L plus one or we have to select one from the maximum possible from the most advantageous from L plus one to the R, or if the current one selects R, then we have no option left but to choose between L and R minus 1, and the recursion moves on. So he will choose the optimal one, which seems to be better for him, like because he will also have a max, and what we are what we know for sure here is player one will always have uh, positive value, and we are taking a negative value from player 2, and if player 2 ends up successful, then the final answer we will get will also be negative, but if player 1 is successful, then we'll get a positive answer. That's what we're checking here. So if it is equals to 0, that means both of them are tied. Let me submit this, and if it works fine, let's discuss our intuition with the ChatGPT and confirm whether our idea is clear or not. So Here I am choosing the I actually I can choose between and and at each turn and player one uh, accumulates his score on the positive side of the num- number scale and player two on the negative side. If player and both the players are balanced out, if both the players are balanced out, with the even scores are even, then will end up at zero. Here, since we are using max we are adding advantage to the player one at each step. Okay, okay, and player one picks numbers on the game. Okay, but the opponent then plays optimally and reduces disadvantage by. So the overall advantage is player one picks lefty You don't explicitly simulate players because when it is player to turn, they are the current player. The recursive also advantage naturally reduces the advantage that player to achieve the same as negative advantage for player one. The subtracting advantage correctly accounts for minimizing player one's advantage. You now understand this. Maximum advantage the current player can enforce over the opponent. Picking left gives, picking right gives. Current player chooses the better one using max. If player one's total advantage at the starting is greater than then okay. The bottom of deviation auto pays up to make the version. We are minimizing the advantage of player two by selecting maximum of both. And if we want player two to full, we should choose minimum since his side of course is always on the negative. For minimum, let's see one thing. Let's print player one. Now let's print left and right. 2 true, false, true, false, true, false, true. Why true multiple times? Okay, okay. So he got to the final position again. He has 2, minus 2 and plus 2. So false means choosing for choosing between minus 2 and plus 2. 53, 41. If we do plus 2 to 49, 51. Okay. Between 6 and 8. 8 minus 6 and 6 minus 8. Okay. So we go through each one and finally came to a position where we have only 2 left. So what can undo? Either choose 6. It's not the final answer. So if you choose a 6, then player 2 will become minus 2. If you choose 8, or if you choose 8, then we'll have minus 2. If you choose 6, we'll have 2. Between 55 and 6, 65 and 8. So here if we choose 8, then we'll have 55 and 6. Or if we choose 6, then if we choose 8, then 55 and 6, okay. Or else we'll have 55 and 8. Leaving 6 as the final choice. We can choose 4, and if 8 is selected, then we can have 6, or if it is not selected, then we can have 8, and for 2, if it is selected, then 2 comma 6, if not 2 comma 8. Even when my feet So that's it, guys. I hope you guys understood the intuition. Let's take a small break to process the information. We'll have to implement it if we have to in a for a next like for a different problem. So for that we'll have to process this carefully. Let's see the insights from this and process them, uh, gain some knowledge. That's all for now. We'll meet you again with another video. Until then, keep learning and keep it smart, guys. And goodbye. Thank you for choosing your channel again.